Welcome to mathema-six number system. What is the number system? Actually, there are several number systems. You already know the natural numbers, also called the counting numbers, 0, 1, 2, 3, and so forth. We'll be working with the rational number system. Rational numbers include the natural numbers plus negative numbers. So 0, 1, 2, 3, and then 0, -1, -2, -3, and so forth. Fractions are also part of the rational number system. Let's take a look at fractions. In the rational number system, fractions are on the number line, sandwiched between their nearest integers. Just like whole numbers, fractions can be negative or positive. To refresh your memory, you multiply fractions across. 1 divided by 4 times 3 divided by 8 equals 1 times 3 divided by 4 times 8, which equals 3 over 32. What does it mean to divide a fraction by a fraction? Let's take a deeper look. You know that when you divide a whole number by a whole number, the quotient is smaller. The whole is equal to 1. Here the whole green graphic. 1 is divided by 4 equals 1/4, and 1/4 is less than 1. Did you know that when you divide a fraction by a whole number, the quotient is also smaller? This piece is equal to 3/4, as you can see. 3/4 divided by 3 equals 1/4, and 1/4 is less than 3/4. And did you notice that the quotient is 1/4 of the whole, but the piece is 1/3 of the 3/4 piece? Did you know that when you divide a fraction between 0 and 1 by another fraction between 0 and 1, the quotient is larger? The idea that dividing a number produces a larger result is counterintuitive. Let's explore the mechanics of dividing by a fraction first. So the standard division procedure is term 1 divided by term 2 equals term 1 times 1 over term 2. Let's assume that term 1 equals 1/4 and that term 2 equals 3/4. So that's 1/4 divided by 3/4 equals 1/4 times 1 over quantity 3/4, and that's equal to the quotient. Let's multiply each side of the equation by 3/4 and simplify, and then multiply each side of the equation by 4/3 and simplify. And we have 1/4 times 4/3 equals the quotient. So the standard procedure for division applies to fractions as well. For fractions, simply flip the numerator and denominator in term 2. Another way to look at the last problem is that 1/4 divided by 3/4 equals 1/3, because 3/4 of 1/3 equals 1/4. In general, A divided by B divided by C divided by D equals AD divided by BC. Problem 1. 6 students are going to share a ½ gallon of chocolate chip ice cream equally. Expressed as a fraction of a gallon, how much ice cream will each student get? The answer is 1/2 gallon divided by 6 students equals 1/2 divided by 6 equals 1/2 times 1/6 equals 1/12. There's 1/8 of a pie in the refrigerator with your name on it. A serving size is usually 1/4 of a pie. It's a small pie. How many servings of pie are there? So visualize standard 1/4 of a pie serving, and you have 1/8 of a pie in the refrigerator. So your intuition should tell you that 1/8 of a pie is half of 1/4 of a pie. So let's look at the math. 1/8 divided by 1/4 equals 1/8 times 4 equals 1/2 of a serving. Note that 1/2 is greater than 1/8. Here's your example when you divide by a fraction between 0 and 1. And problem 3. Central Park in New York City is basically a rectangle. It's about 1¼ miles square miles in area and about 1/2 mile wide. What is the length in miles? Well, you know that rectangle is length times width. Find the area. So the surface area equals length times width equals 5/4. That's 1¼ square mile. So then we will solve for length. 5/4 divided by 1/2 equals 2.5 miles long. You are probably a star at operating at numbers from 0 to 99, but now it's time to step up your game. We're going to tackle multi-digit number operations using the same procedures, only the size of the number adds complexity. How would you go about finding the quotient of 32 divided by 512? The tips are line up the decimal points in the dividend and the quotient. Put in as many zeros to the right of the dividend's decimal point as you need to compute a quotient. Here we've added 4 zeros to the right of the decimal point for 32, and we've lined up the decimal point for 32 with the decimal point above it for the quotient. Steps are in the slides. You can go through them one by one. We won't go through them here. But it's a standard procedure, and you should have no problem with it. Now let's try adding two large numbers with decimals. Tips are line up your decimal points, start adding from the right, and jot down every carry forward number if you find it hard to remember. So there are the steps. And again, this is standard addition. Just make sure that you line up your decimal points and add correctly. Now let's try subtracting a large number from another large number, both with decimals. Line up your decimal points and start from the right. You can check your work by adding the result in the second term. They should equal the first term. In this example, we add 876.54 and the result 2890.36, we should get 3766.90. Here are the steps when you go through the slide. And finally, let's look at multiplying big numbers, both with decimals. You do not have to line up your decimal points with multiplication. You do have to stagger the computation lines as noted. Count the number of digits to the right of the decimal places in the two terms and use this number to determine where to put the decimal place in the final result. In this case, 479.35 has two digits to the right of the decimal point, and 28.14 also has two digits. So 2 plus 2 equals 4. We can expect to put our decimal point 4 digits in from the right in the result. And if you look at 13488.9090, the decimal point is 4 digits to the right, from the right. That ends the first half of the mathema-six number system module movie. Please watch the second half before you move on to the slides.